Right, so the next thing we're going to look at today is basically the basic operations with graphs, so adding, subtracting, and so on. So let's start off with adding and subtracting, sometimes called superpositioning. It's a nice fancy word. If you want to add two graphs together, well, the easiest way is to draw the two individual graphs as a bit of a construction. So y equals x, y equals 1 on x, and we want to physically add all the y values. So you pick key points to add together. So points of intersection would be obvious one, because you're just going to double whatever that y value is. And you just keep plotting points until you get a feel for the curve. Now, I always tend to add whatever one's underneath to the above one, so I can swap between the two. So when I start at the y-axis here, it's the line I'm adding to the hyperbola, whereas once I get past the point of intersection, I think of it as the hyperbola adding to the line. But you can see the y values of the hyperbola, as we are going along the x-axis, are getting closer and closer to 0. So it makes sense that y equals x ends up being an asymptote, because we're going to get closer and closer to y equals x. We're going to be adding smaller and smaller amounts. So let's just, there we go, there's our red curve, y equals x plus 1 on x. When we are adding, things to keep in mind. Discontinuities. If there's a discontinuity in one of the functions, it's going to remain in the new function. I mean, if it didn't exist in the original function, how on earth is it all of a sudden going to exist in the new function? So ones like we just looked at, x equals 0 in the last one that we looked at was an asymptote, a vertical asymptote, and that remained. Similar with 1 minus 1 on x, that would remain. So if I was to add these two together though, I get the line y equals x plus 1. However, it's not going to be the line y equals x plus 1, because x can't equal 0. See, we're not drawing the graph of y equals x plus 1. We're drawing the graph of x plus 1 on x plus 1 minus 1 on x. And I can't substitute x equals 0 into that. So we end up with what looks like the line y equals x plus 1, but at the x value of 0, we'd have a point discontinuity, because we couldn't actually physically substitute that in. X-intercepts. So if function x equals minus g of x, that's going to create the x-intercept. So what we're saying is the y value above is equal to the y value below on the other curve, so when you add them together you get 0. So I guess the way I do that with mine is I can slide a ruler along the x-axis, and when I get the same number of centimetres above as I do below, I go, all right, bang, I know that's where the x-intercept is. Symmetry. Like functions retain symmetry. Like functions obtain symmetry. So if you're going to add an odd function with an odd function, it'll still be an odd function. If you add an even function with an even function, it'll still be an even function. How if you add an odd with an even, it's going to lose its symmetry. Ah, yes, this good old one. Absolute value plus absolute value. Now, if you remember how absolute value is formally defined, remember the actual definition for absolute value of something is equal to a when a is greater than or equal to 0, but equal to negative a when a is less than 0. That's why when we were solving absolute value equations, we said either the positive was equal to this or the negative was equal to this. So that point where it changes from positive to negative becomes important, and that's what we end up investigating. So inside the absolute value sign I have x plus 3. Well, it's at negative 3 is when that changes from positive to negative. In other words, what makes it equal to 0? 1 will become an important point as well. So first of all, let's look at what happens when x is a negative number. So you can think of any negative number you like and just substitute it in. See what happens. But basically, if I substitute into x plus 3, I know I'm going to end up with a negative number. So when I have a negative number, it'll be the negative of x plus 3. Sub it into 1 minus x, we get a positive number. So when it's positive, it'll stay as 1 minus x. Add the two together, I end up with the line y equals minus 2x minus 2. So for x is less than or equal to negative 3, that's the line I would draw. Okay. So now let's have a look in between those two key points, minus 3 and 1. 0 is probably an easy one to check if we're unsure. X plus 3 would be positive. 1 minus x, also positive. And so in between the two, I'm going to draw y equals 4. And then when x is greater than or equal to 1, x plus 3, that's going to be positive. 1 minus x, that'll end up being negative. Add those two together and I'll draw the line 2x plus 2. So that means this graph will look like, there's the first section, so I'm just drawing minus 2x minus 2. Then the horizontal line, y equals 4 until we get to an x value of 1. And then from there we draw the line y equals 2x plus 2. So I find that personally easier than drawing the two absolute value graphs and doing the superpositioning. I mean, you could still do that if you wanted to. Now, if you had to draw a function x minus another function, I tend to still think of it as addition, but I add the negative curve. So if I wanted x minus sine x, so there's y equals x, but I don't draw y equals sine x, I would draw y equals minus sine x. And so instead of it becoming a subtraction, it's now an addition. I'm adding, and I can do exactly the same as I did before. So the point of intersection there is, well, it's 0, and twice 0 is 0. But every one of these x-intercepts becomes interesting, because if it's an x-intercept, that means I'm adding nothing to the other curve. So the point will be on the other curve, in this case, the straight line. So every one of those x-intercepts, although on the scale I've done I can only mark in a couple of them, but they will all be on the red line. And what we're going to end up with is a sine curve winding along the line y equals x. But it's not symmetric. It actually, let's draw a few more points in. So you'll notice it's not symmetric. The peak, if you like, is towards the 0 in here rather than halfway. And that's all to do with, because the y equals x is at an angle, and you're adding vertical distances rather than perpendicular distances. And so you still get a nice periodic curve. It would keep winding along y equals x, but not in a nice, neat pattern. So 8b is on adding and subtracting.